All right, so Module 9, Homework 3. This is talking about systems of linear equations and two variables. So basically, we've been talking about one line, one equation this whole time.
Yep.
So it's saying, what if we put two lines together? So we put two lines together, that's a system of equations, system of linear equations. And if I want to find out the solution, I want to try to see where those two lines cross. I want to see where those two lines intersect. So that's what this whole section's about. We're going to find that using three different methods. We need to know all three methods for the test because it'll ask you to solve it all three ways. And you have to do it the way that it tells you. So in this section, we're going to determine if an ordered pair is a solution to the system. We're going to find the solution by graphing, substitution, and elimination. So those are our three methods that we're going to use. Like I said earlier, that you need to know all three methods because it says solve by graphing. You have to graph it. It says solve by substitution. You have to follow the directions. All right, anyways, so this first example says determine which of the graphs is a system of equations that has no solution. So I just said that the solution is the point where the two lines cross. Close. Has no intersection. Okay, so let's look at let's skip part A for a second. Okay, for B, how many solutions, how many times do these two lines cross? One, so we have one unique solution. So this point right here is the one solution where the two lines cross. What do you notice about C?
They never cross.
They never cross, they're parallel. So if they never cross, how many solutions do we have?
Zero.
Good. So no solution. We're looking for no solution, so that's our answer. But let's keep going. Option D, how many times do these two lines cross? One, so one unique solution. They cross one time, so that's our solution.
Are you going to tell me A is infinity?
Ooh.
Because they're on top of each other.
Bingo, nailed it. So A, yes, it's a system, so that means there's two lines. I only see one line. That must mean that the two lines are on top of each other. So they intersect at every single point, and it goes on forever. So we have, I don't know if this is really mathematically correct, but infinitely many solutions. This is two lines. Oops. On top of each other. So they intersect at every single point and it goes on forever, so infinitely many solutions. So our answer to that question was, which one has no solution? And that was C, our parallel lines, because they will never cross. Looking at our next example, it says determine which of the graphs has a solution at 1, -6. So where A, B, C, or D do these lines cross at 1, -6? C. They cross down here. This point looks at over 1, down -6. So the solution is an ordered pair, is a point, x, y, and that's the point of intersections where these two lines cross. Questions, comments, or concerns for me thus far? So our next example says determine whether 5, -5 is a solution. So in order for it to be a solution, it has to be 5, -5 has to be a point of the first line, it has to be a point of the second line. Bless you. Bless you. Done?
I think so.
Okay, I thought you had to go for 3. I was waiting for the third one. So I'm going to plug 5, -5 into the first equation, see if it works. Plug it into the second equation, see if it works. If it works for both of them, then yes, it's a solution. If it does not work for either one, then our answer is no. So 5, -5, this is our ordered pair. So x is +5, y is -5. There you go. Bless you. I knew it was coming. So first plugging it into x minus y equals 10. So 5 minus -5 equals 10. Those two negatives become a positive. So 5 plus 5 equals 10. So 10 equals 10. It worked for the first one.
It does not work for the second.
All right, let's see. Let's plug it into the second one. So 9x minus 2y equals 35. Plugging in x is positive 5, y is negative 5. So 9 times 5 minus 2 times negative 5 equals 35. 9 times 5 will give us 45. Negative 2 times negative 5 is positive 10 equals 35. 45 plus 10 is 55. 55 does not equal 35, so it did not work. So no, not a solution. No, not a solution. Same thing for the next one. Try the next one by yourself. Determine whether 3, 4 is a solution to the system. The system is 5x minus 4y equals negative 1, and negative 4x plus 2y equals negative 4. So plug in that ordered pair to both equations like we just did, and see if it works. It has to work for both of them. I know you're doing your stuff. I didn't want you to feel left out. All right, looking to see what you did, looking to see what we did together. So for our first line, we have 5x minus 4y equals negative 1. If we plug in 3 for x, 4 for y, 5 times 3 minus 4 times 4 equals negative 1. That'll give us 15 minus 16 equals negative 1. So yes, negative 1 equals negative 1. 3, 4 is a point on that first line. Same thing for our next line, negative 4x plus 2y equals negative 4. Plugging in x equals 3, y equals 4. We get negative 4 times 3 plus 2 times 4 equals negative 4. That'll give us negative 12 plus 8 equals negative 4. So again, yes, negative 4 equals negative 4. 3, 4 is a point in that line. So meaning that they both have the point 3, 4 in common. So that means they will both cross at the point 3, 4. So yes, that is our solution. Questions, comments, concerns from me thus far? If not, let's keep going. So now let's actually find the solution ourselves. So our first method of solving systems of linear equations is to solve by graphing. So we're going to graph each line separately, and we're going to see where the two lines cross, where the two graphs cross. So solve by graphing x plus y equals negative 2, and 3x x plus y equals negative 2, and x minus 3y equals 18. So, okay. Let's graph the first one. X plus y equals negative 2. I want to put this into slope-intercept form so that way I can find the slope and the y-intercept.
Did you just sum both to 0?
You can do that too. Yeah, you can find the intercepts and put x equals 0, y equals 0. You can do that too. Either way.
X equals negative 2, y equals negative 2.
Yeah, you'll get the same answer. This is just the way that most people do it, so that's why I was doing it this way. But you'll get the same thing.
Okay.
So great point. Thank you for bringing that up. So if I were to subtract x from both sides, I would get y equals negative x minus 2. So this is now in our slope-intercept form, which is y equals mx plus b. So we can see that our slope is negative 1, which if it helps you to write it as -1/1. So that way I know my rise is -1, meaning I'm going down 1. My run is +1, so going in the positive direction, we're going to go right 1. So down 1, right 1, but I have to have a starting point. Our B value is -2, so our starting point is 0, B, which is 0, -2. So that's where we're going to start. So 0, -2 over 0, down 2 is our starting point. From there, I need another point, so I'm going to go down 1, right 1. Down 1, right 1. I was going to do a couple other points because I'm not very good at drawing straight lines. So down 1, right 1, down 1, right 1, down 1, right 1. Just so that way I can have a couple more lines so it's easier for me to draw a straight line. That's the problem with this method. You have to be super neat. They're trying to see where these two lines cross. So that's our first line. We're going to do the same thing for our second line. X minus 3y equals 18. Getting y by itself, we're going to subtract x from both sides. So -3y equals -x plus 18. Dividing both sides by -3. I have y equals -x divided by -3 plus 18 divided by -3, which will give us y equals -x divided by -3 is +1/3 x. 18 divided by -3 is -6. So now that I had this in slope-intercept form, which is y equals mx plus b, we can see our slope is +1/3. So I'm going to rise or go up 1, and I'm going to run or go to the right 3. And our b value is -6. So our starting point, which is 0b, is going to be 0, -6. So we're going to start at 0, -6. Separating the two lines. Starting at 0, -6, we're going to go up 1 and right 3. So starting at 0, -6 as my starting point. To find my next point, I'm going to go up 1, right 3. 1, 2, 3. Boom, there's my second line. Let's go ahead and connect those dots. Bless you.
Teacher cheating with the ruler.
You're more than welcome to bring a ruler. I cannot draw a straight line to save my life without a ruler, so. And I think you guys know that.
Mm-hmm.
You've witnessed it, unfortunately. What?
Huh?
What?
So who can't actually draw?
I know. I don't know. I feel like it's still not even straight with the ruler, but whatever, it's good enough. Okay, so these two lines cross. That's what we're looking for. That's our solution at this point right here, which is over 3, down 1, 2, 3, 4, 5. So over 3, down -5. So 3, -5 is the point where they cross. So that is our solution. The ordered pair, 3, -5, over 3, down 5. It's super important. Our solution is a point. So we need to write it as a point. We need to write it as our ordered pair. We need to write it as an ordered pair. Questions, comments from me so far? If not, if you want to try the next one by yourself, go for it. I'm going to do it up here. But if you want to try it by yourself to make sure you don't have any questions, please go for it. So for the next one, we're also going to solve the system by graphing 4y minus 8x equals 0, and x plus 2y equals 5. So same thing as the previous problem. Taking my 4y minus 8x equals 0. I want to put this into slope-intercept form so that way I can find the slope and the y-intercept. And I can graph it. So getting y by itself, I can add 8x to both sides. So 4y equals 8x plus 0, if you want to do that. Lastly, getting x by itself, we're going to divide both sides by 4. So we have y equals 8x divided by 4 plus 0 divided by 4.
Error.
That'll give us y equals 8x divided by 4 will give us 2x. 0 divided by 4 though.
Error.
Close. Put in your calculator. 0 divided by 4.
0.
0. Remember, it's error good whenever it's the opposite, whenever it's 0 on the bottom. So 4 divided by 0 will give us an error. So plus 0. You don't really need this plus 0, but I'm going to leave it there so that way I can easily identify this in y equals mx plus b form. So I can now easily see that my slope is 2, which is 2 over 1. So my rise is 2, I'm going to go up 2. My run is positive 1, so I'm going to go to the right 1. From my starting point, my b value is 0. So 0 comma b is my starting point, which will be 0, 0. That's my starting point. So starting at 0, 0. Starting at 0, 0. I want to find the next point based off of our slope. So I'm going to go up 2, right 1. Let's do another one. Up 2, right 1. Oops. So there's my first line. I'm going to connect the dots. And we're going to do the same thing for the next line. So x plus 2y equals 5. Again, putting this in y equals mx plus b form, we're going to try to solve for y to get y by itself. So we're going to subtract x from both sides. So 2y equals negative x plus 5. Last but not least, getting y by itself, I'm dividing both sides by 2. So that will give us y equals negative x divided by 2 plus 5 divided by 2, which will give us y equals negative 1/2 x plus 5 divided by 2. This is now in y equals mx plus b, slope-intercept form. So we can easily see that our m value is negative 1/2. So that means that my rise is negative 1. So I'm going to go down 1. My run is positive 2. So that means I'm going to go to the right 2. Our b value is 5 over 2, which if it helps you to put it in decimal form, that's 2.5, so 2.5. So that means my starting point, which is 0 comma b, is 0 comma 5 over 2, which is 0 comma 2.5. So even though it's a fraction, we can still do it. So starting at 0 comma 2.5, so over 0 up 2.5. My next point, I'm going to go down 1, right 2. So I'm at 2.5 going down 1 to 1.5 over 2 is my second point. So if I'm at 2.5 going down 1 unit, I'll be at 1.5 over 2 over 2. Connecting the dots. Wasn't even close. Just make them bigger. Where the ruler wasn't even close. I really want to erase that, but whatever. So we can see that they two lines cross at this point if I drew it right here. Oh, sorry, OCD can't do it. Let me do it this way so I can see it better. There. The two lines cross at this point right here, which is over 1 up 2. So our final answer, our solution, our ordered pair is 1, 2, over 1 up 2, that point. So if you did it by yourself, or if you did it together with me, before moving on to our next method, this is our first method, solving by graphing. Questions, comments, concerns for me. Have most of us done this before? And just refresher.
I like it there on the computer. You can create
Yes, the
straight
computer
lines.
graphs it for us. We get a little spoiled.
You can graph better straight lines.
Yeah, you can graph better straight lines. All right, so if no questions, let's go on to our next method.
Normally, you can use calculator.
Yeah.
Brackets, over hands.
We're going to learn how to use the graphing calculator next semester, college algebra. All right, so our next method is solving by substitution. So as of right now, I have two lines, and each line has two variables. We have an x and we have a y. I cannot solve if I have two variables. I can't get x equal or y equals when there's two unknowns. So in order to make there only be one unknown and to solve for x and y, we can use what's called the substitution method. So it asks us to use the substitution method to solve the following systems of equations. Our system is x plus y equals 24 and y equals 7x. So what I want to do is I want to substitute one variable in for another. This one's kind of already set up for us. We know that y equals 7x. So that means instead of y in our first equation, we can substitute 7x because y is the same thing as saying 7x. So therefore, if we have x plus y equals 24, I know instead of y, I know y is the same thing as saying 7x because y equals 7x. So we now have x plus 7x equals 24. So now I have an equation with only x's in it, where I can get x by itself. Yep, combine like terms. So we substituted y equals 7x into the first equation. Combining like terms, 1x plus 7x's will give us 8x equals 24. Getting x by itself now. We can divide both sides by 8. Now I have to sneeze. So we're left with x equals 24 divided by 8 is 3. So now I know that x is 3. We're halfway done.
Y equals 1.
Good. Now I can plug x into either equation. The second one looks easier to me, but either one you'll get the same answer. So y equals 7x. I know that x is 3, so I can plug that in. So y equals 7 times 3. So y equals 21. So we plugged x equals 3 into either equation to solve for y. So I now know my answer is the ordered pair x comma y, so 3 comma 21. So I went ahead, these are the answer choices straight from my math lab. I just retyped them out. We either have one solution, we have the solution is the whole line, so this will be for infinitely many solutions. Or the solution set is empty set, so no solution. We got one solution, which is 321, so I'm going to choose answer choice A. There is one solution, and the solution of the system is the ordered pair 3 comma 21. So that's how it will look like on my math lab. So we're going to do one more of these. Before we do the one more of these, questions, comments, concerns from me, please.
That's about it.
We're good. So next example. So using the substitution method to solve the following systems of equations, 4y minus 8x equals 0, and x plus 2y equals 5. Last time it was easier because they already gave us y equals. They already kind of did some of the steps for us. So I want to try to take either equation and either solve for x equals or get y equals. Doesn't matter which x equals or y equals, doesn't matter which equation. Looking at this, to me, on our second equation, we have 4y minus 8x equals 0 and x plus 2y equals 5. Looking at this on the second equation, x plus 2y equals 5, x is somewhat already by itself. So it's kind of somewhat done for us a little bit. So let's do x plus 2y equals 5. And let's get x by itself completely. So I can subtract 2x from both sides. So we're going to take either equation and solve for x or y. So we took the second equation and we're getting x by itself. So we can subtract 2y from both sides and we get x equals 5 minus 2y. So now I know x equals 5 minus 2y. I can take that and I can plug it back into the other equation. So plugging it into 4y minus 8x equals 0. Instead of x, I know x is the same thing as saying 5 minus 2y. So I can plug that in. I can substitute that. So we now have 4y minus 8 times 5 minus 2y equals 0. So now I have an equation with only y, so I can solve for y. I can substitute our x equals into the other equation and I can solve for y. So to do so, I'm going to distribute that negative 8. So 4y minus 40. Negative 8 times positive 5 is negative 40. Negative 8 times negative 2y is positive 16y equals 0. Combining like terms, 4y plus 16y will give us 20y's minus 40 equals 0. Getting y by itself, we can add 40 to both sides. So 20y equals 40. And last but not least, getting y by itself, we can divide both sides by 20. So we get y equals 40 divided by 20, which is 2. So we get y equals 2. We're halfway done. We are halfway done. Now we just need to get what x equals. So I can take y equals 2. I can plug it back into either equation, either the first one or the second one, doesn't matter, and get x by itself. I'm going to choose the second equation just because it looks a little bit easier. So x plus 2y equals 5. And we are going to plug y equals 2 into either equation to solve for x. So we said y equals 2, so we have x plus 2 times 2 equals 5. That'll give us x plus 4 equals 5. Getting x by itself, we can subtract 4 from both sides, and we get x equals 5 minus 4, which is 1. So our final answer is the ordered pair, 1, 2. We got one solution, so our answer choice is there's one solution, so answer choice A, and the solution is 1, 2. 1, 2. Questions, comments, concerns from me so far? If not, we're going to do our last method. We did graphing. We did solving by substitution. Our last one is solving by elimination. Solving by elimination. So next page. Use the system to solve use elimination method to solve the following systems of equations. We have 4x plus y equals 10 and x minus 2y equals 7. So last time we got x equals or y equals and we substituted that in to an equation. Now I want to eliminate. So if I were to add these two equations together, I want to eliminate either x or y. If I were to add these two equations together right now, we have 4x plus 1x, which is 5x. Don't eliminate. Y minus 2y, which will give us negative y. They don't eliminate. So I need to make them eliminate. You can multiply and either eliminate x or y. It's totally up to you. I see that on the second equation, my y, I hate my chip nails, so don't look at my nails. You see y equals, that's like my pet peeve, but I didn't have time to repaint them. So negative 2y, what was I saying? Yeah, negative 2y. So if I were to add these two equations, if the top one was positive 2y, negative 2y cancel each other out, right? Sure. So in order to make this positive 2y, I need to multiply everything on the top equation by positive 2. So I want to distribute positive 2 to everything on the top equation on both sides of the equal sign. So that will give us 2 times 4x is 8x. 2 times y is plus 2y equals 2 times 10 is 20. The bottom equation is already negative 2y, and that's what I want, so I'm going to leave it exactly the same. So x minus 2y equals 7. So now I can add these two equations together. So I made it work. I made it where the top one's positive 2y, the bottom's negative 2y. So when I add these together, I know they're going to eliminate, they're going to cancel out. So adding the two together, 8x plus 1x is 9x. 9x. Yeah, 2y minus 2y eliminate. They cancel each other out, which is what we wanted. Equals 20 plus 7, which is 27. Going up here, 9x equals 27. Getting x by itself. Dividing both sides by 9. We get x equals 3. We're halfway done, so now that x equals 3, just like on the previous examples, I can plug in x equals 3 to either equation and get y by itself. I want to try to get y by itself. The first equation kind of already has a little bit y by itself, so I want to plug that into our first one. So 4x plus y equals 10. I'm going to plug in x equals 3, so 4 times 3 plus y equals 10. 4 times 3 is 12. Plus y equals 10. Subtracting 12 from both sides to get y by itself. We're left with y equals 10 minus 12, which is negative 2. So we got the ordered pair x comma y as 3 comma negative 2 as our final answer. Boom goes the dynamite. Notice that there's one answer, so our answer choice is A. And that's 3 comma negative 2. So our first step is we multiplied to make one variable cancel out or eliminate. Then we solved. And then we plugged in x equals 3 into either equation to solve for y. Questions, comments, concerns for me, please. So let's do one more of these examples. It asks us to use the elimination method to solve the following equation. X minus 4y equals 13. and 4x minus 16y equals 13. So I can either eliminate x or y, doesn't matter. What do you want to do?
Either way, you're going to exit out the
Okay. So let's see. So if the bottom equation is positive 4x, I know the top equation should be negative 4x, and they'll cancel out, right? So let's multiply this top equation on both sides of the equal sign by negative 4. I'm going to come down here. So negative 4 times x is negative 4x.
Plus 16y.
Good. So negative 4 times negative 4y is plus 16y equals negative 4 times 13.
52.
Negative 52. Yes? The bottom equation is already positive 4x, so it's already good to go. So we're going to leave it as 4x minus 16y equals 13. So now whenever we add these two equations together, negative 4x plus 4x, eliminate, they cancel out. 16y minus 16y, they eliminate, they cancel out. So what's left on the left-hand side?
Just a number.
On the left-hand side? Yeah.
Oh, nothing.
Yeah, nothing. So 0 equals negative 52 plus 13 is negative 39. Does 0 equal negative 39? No.
No solution.
False statement, so no solution. So no solution. These two lines never cross. So that will be answer choice C on my math lab. The solution set is empty set. There is no solution. Our set of solutions is empty. Questions, comments, concerns for me? All right, so it asks us to solve the system of equations 2x plus 6y equals 6 and 3x plus 9y equals 9. It does not specify what method to use, so you can use whatever method that you want. So for this one, it would be, looks like it's a little bit trickier to get x equals or y equals because there's numbers in front of everything. So I'm going to use the elimination method. But you can use substitution method or elimination method, whatever one that you like better. So we are going to use the elimination method. And we want to eliminate either x or y. On this one, it doesn't look like either one's easier than the other, so let's go ahead and eliminate x. So if I have 2x, I have 2x plus 6y equals 6 and 3x plus 9y equals 9. So if I have 2x's plus 3x, they do not eliminate as they are, but I can make the first one positive 6x and I can make the second one negative 6x. That way they'll cancel. So to make the top one positive 6x, I need to multiply every single term by 3 on both sides of the equation. And to make the bottom variable negative 6x, I need to multiply everything by a negative 2 on both sides of the equation. So that will give us 3 times 2x is 6x. 3 times 6y will give us plus 18y equals 3 times 6, which will give us positive 18. On the bottom, negative 2. So negative 2 times 3x is negative 6x. Negative 2 times 9y is negative 18y equals negative 2 times 9, which is negative 18. So now whenever we add these two equations together, 6x minus 6x eliminate goes to 0, which is what we wanted. 18y minus 18y also goes to 0, so they also cancel each other out. So we're left with 0 equals 18 minus 18 will also give us 0. They also eliminate. So we have 0 equals 0. That is a true statement. So because it's a true statement, that means every single point will give us a true statement. So that means every single point is the same. So that means we have infinitely many solutions. Infinitely many solutions. They cross at every single point. So We have one more example. Which is 12x plus 4y equals 13, and 3x plus y equals negative 13. Again, it doesn't tell us what method, so I can use whatever method that I want. The second equation kind of already has a little bit y by itself, so I'm going to use substitution. Method. So I can get y by itself, so 3x plus y equals negative 13. Getting y by itself, I could subtract 3x from both sides. That way 3x minus 3x cancels, and we're left with y equals negative 13 minus 3x. I can now take that y equals and I can substitute it into my other equation. So my other equation is 12x plus 4y equals 13. I can plug my y equals into this equation. So we have 12x plus 4. Instead of y, I know y is negative 13 minus 3x equals 13. So now I can use this and I can get y by itself. I'm sorry, x by itself. So 12x plus 4 times negative 13 minus 3x equals 13. I can get x by itself. So I can distribute this 4. So we have 12x. 4 times negative 13 is negative 52. 4 times negative 3x is negative 12x equals 13. Combining like terms, 12x minus 12x goes to 0. They cancel each other out. So we're left with negative 52 equals 13. That is not true. That is a false statement. Negative 52 does not equal 13. So that means no solution. Which in my math lab, they use the empty set symbol. That shows us no solution. So that is Module 9, Homework 3 notes.